Okay, I'm going to write the motivation and the statement of the problem. So we are interested in solving nonlinear equation. Then I will just copy the text and then I'll first paste it instead of this motivation and whatever I will just say. So in this paper, we are interested in suggesting an alternative approach structural algorithm for solving nonlinear equation of the form. Now I have an equation, so I have to use begin equation, end equation, because it's a numbered equation. So I have to use begin equation, end equation. Then I'll put the equation, maybe f of x is equals to 0. So that is it. So I'm interested in solving the equation of the form f of x is equals to 0, where f is a mapping from R n to itself and whatever. So I will just copy and then we'll paste it there after the equation. So this equation I can level it, level, then I put the key maybe eq1, so I so that if I can refer to it. So where f, capital F, is a mass mod, is a non-linear mapping from Rn to itself. So from backslash math bb r math bv rn for n. So this is a mass mod. I suppose to put it in mass mod $. So from Rn into itself, and the Jacobian of f, not g. The Jacobian of f is not obtainable or require large amount of storage. The system of nonlinear equation has various applications from sciences, engineering, and economics. So I think this is okay for the statement of the problem. Let me see if I have used the package AMS math. So I didn't use it. I have to upload it here because you see I use equations and whatever. So use package, then the package name AMS math. Look at it here, and then I also need AMS symbol, sim, and then I also need AMS theorem, AMS THM. Yes, but this is okay. So then I will put something in itemized form. For example, since I'm just doing in maybe what do you call it, presentation, so itemization is very good to use here. So maybe I wanted to talk about the method for solving equation 1. So let me just put them in itemized form. In itemized form, we can say Newton's method is a popular. This one is not from a paper. I didn't copy it from it. I just come it by head because I know the method that we use to solve equation 1. So Newton's method is a popular method for solving. So instead of putting equation 1, I will just put equation, then I just refer backslash ref, then I'll put eq1. So that's it, automatically refer to it. Newton's method is popular method for solving equation 1. Right? Yeah. But what is its problem? It has some shortcoming or drawbacks. So Newton method demand the computation of the Jacobian matrix, which require the first order derivative. So I will put it also in itemized form. Well, let me just say it requires, since I am talking about Newton method, it requires the computation of the Jacobian matrix, which require first order derivative. So based on this, then it is not suitable as another item. Therefore, Newton's method and its variants are not suitable for large scale system or for solving large scale systems of equations. Okay, so that is some shortcomings or drawbacks of the Newton methods. And then this is part of my motivation or our motivation for the research. Because of this problem, we are now trying to generate or to develop a matrix-free method. The method that doesn't require Jacobian, that is first order derivative, which definitely will be suitable for solving large scale system of equation. So let me just compile to see how my first slide is before I continue to the next slide. The next slide will be now still is about motivation, since I said it's at least two. I think it's at least two. Is it two? Yeah, at least two slides. So I can have more than even two slides, but I think in this one I only need so still my slide is not where is the okay. So this is the whole slide, as you can see. Slide 1, you see, correct. So this is the first slide. Then I wanted to continue with my motivation in the second slide. So I am not going to background theorem, still I am in under motivation and statement. So all I have to do is to open a new frame. So let's say begin frame, M frame. Then I'll put the content. Then first of all, I need the title of the frame. So it's just a continuation of the motivation and statement of the problem. If I like, I can put it. If I didn't like, I mean just leave it without frame title, so that when I'm presenting, I will just refer to the previous frame title as the frame title of this frame. So next thing is that I wanted now to talk about the method I am trying to develop. So but I am not the only person that start developing that method, because there is an existing method which we call the spectral gradient or spectral algorithm. In short, we call it DF-SANI for solving, which was proposed by some authors for solving large-scale nonlinear system of equations. So I'm going to put I'm going to use items, begin itemize. I'm going to put all what is inside this slide as an itemized item. So I will start begin itemize, then item 1, I want to talk about that existing method. So the spectral algorithm. The spectral algorithm in bracket DF-SANI. With this DF-SANI, I wanted to use TeXT TeXT like this. I want to put it in TeXT typewriter. So the spectral algorithm was initially proposed by Lacroix, Martinez and Reiden. But I just start with spectral algorithm. Before the itemize, I have to say that matrix free method free methods exist in the literature. This method, okay, full stop. These methods are designed specifically. So this is just coming out from my head. So these methods are designed specifically for or to overcome the drawbacks of Newton's like method in solving large scale problems. Okay, then we said the most popular okay, I think I made a mistake. The most popular method is, then that is the spectral algorithm DSNE, initially proposed by Lacroix, Martinez and Reiden. Then I have to cite the paper here in which Lacroix, Martinez and Reiden presented this kind of algorithm. So I wanted to use a footnote style to put the citation. So maybe let me just copy the citation and put it as a footnote. That will be better. So where is it? Lacroix, Martinez and Reiden. I think this is the paper. So they presented it in 2006. All right. So Lacroix, since I copy it, I have to make sure I retype so many things there. This is Martinez, Reiden, with spectral residual method without gradient information for solving large-scale nonlinear system of equation. That this is a journal name, Mathematics of Computation, but we abbreviate it as Math Compute. So we have the volume is 75, the year is 2006, 2006, and then the pages is page 1429 to 1448. So this is what should be in the footnote. Maybe let me just quickly build and compile and see if I can get what I want before we move on. Aha, let's look at what I have now. Look at it now look at the itemized function, the spectral algorithm, this initiated by Lacroix, Martinez, and look at the footnote. It put it down as a footnote. That is the citation, which is very good way of presentation, as you don't need to cite, so that people will go at the end of the day, maybe at the end of the slide you see your your reference. It's better to go with your reference. If you cite a paper, you put it at a footnote and then put it in that slide so that people can see the paper you are citing. So thank you very much for listening to this video. Maybe we'll move to the next video so that we can continue.